Okay, one of the biggest things that we talk about in statistics, and this is actually starting chapter 3, and I go into chapter 3, there's two parts of chapter 3, maybe three parts of chapter 3. One is finding the mean and standard deviation of a data set. The other is finding the mean and the standard deviation of a frequency distribution. And the third is finding the box plot in the 5-number summary. And then there's the fourth part, finding your z-score. Now the z-score is really going to be used later on in chapter 6 or 7. But you need to learn those 4 things out of chapter 3. That's what I test on. So some of your homework questions, I don't know where they come from. I'm going to have to go through and change some of the homework because some of the questions I'm seeing have nothing to do with what I think is important in a statistics course. So those 4 things is what we're going to harp on. We're going to start on today. I don't know how far we'll get, but we'll get as far as we can. Now, I use the Excel spreadsheet. Now, some of y'all, you don't like Excel. You never worked with it, so you kind of have a redneck disorder about it. I don't want to use it. I've never used it, but I don't want to use it. All right? Don't have that. First of all, don't have that because Excel next to Word is one of the things that you use in the real world the most as far as a desk job, okay? So if you sit at a desk anytime, you're going to be using Excel, all right? So you might as well get used to it and take CPT 170 and get used to doing it. The second thing you need to realize about Excel is I'm not trying to teach you how to use Excel, all right? That is CPT 170's job. That is not my job. So please do not do like the girl that I threw out. She went on there and said, he expects us to learn Excel. Okay? I don't expect you to learn Excel. The reason, and I tell you like I told that class, and I tell all my classes that I use Excel in, I am a very disorganized writer. Okay? You know how some of y'all can write the same way all the way through and write like a page and a half and every letter be the same height? That ain't me. All right? So I can fill up this little whiteboard in a matter of seconds and everything will be disorganized. That's just the way I write on the board. So the reason I use Excel, 98% of the reason I use Excel is to have everything on the board in an organized fashion to where you can see it. You can take a picture of it, whatever the case may be. Okay, so I want to get that straight right now because somebody is going to come up to me at the end of the unit and right before I give a test, and they're going to say, I just don't know how I'm going to pass this test because I can't use Excel. I didn't tell you to use Excel. You need to be writing it in your notes by hand. All right. Then I'll show you after I show you how to do it by hand. And after I show you how to do it on Excel, I'll show you how to do it on the calculator. I show you how to do it on the calculator last for a reason, because of the calculator drill team. The ones that are in high school that, like the drill teams, they use their calculators so fluently. Those are the people that can't make change at the cash register. So I don't want those people around, okay? I want you to learn how to actually think. Yeah, it's that word, bad word. I could teach my 9-year-old how to use a calculator. I could teach a monkey how to use a calculator. All right? Does that tell you how much smarts it takes to use a calculator? Okay? Well, actually, they're pretty smart, so I guess it does take a little bit. But anyway, there's 2 types of data in statistics. There's data-driven, and then there's the frequency distribution. So what I'm going to do is I'm going to set up a data-driven set, and think when you data-driven, that means like test scores. All right. Now I'm going to cover about 3 sections at one time here because everything they spread out. Something as simple as mean, median, mode, range, mid-range. They spread that out by 3 sections in this book, and I'm not going to do that because most of you are intelligent people. I said most. Okay, I didn't say all, I said most. And most of you know that the range is the highest minus the lowest, so I don't need to spend 35 minutes going over the range. Where I need to spend 35 minutes is finding the standard deviation, which is the most important number next to the mean that there is. Okay, so all the different numbers in the data set are called X. So I'm just going to make up some numbers. 75, 76, I'm going to put them in order. 80, 83, 88, 90, and 92. And let's say these are test scores. All right, the first thing you're going to need to decide is, put X right here. I'm going to put X here. And up here, we're going to put N is equal to, N is the number of actual grades. So 1, 2, 3, 4, 6, 7. N is equal to 7. Remember, N is always your total. Okay? Now, there's several things that you need to be able to find with data-driven and frequency distributions, and that is the two things that are most important is the mean and standard deviation. But there's other things that you can find with data-driven so that you can let the numbers tell you what's going on. Okay? And I don't think I've really done anything to cause discussion or anything, so everybody should be listening, not talking to each other. Okay? So the first thing you need to do is find the mean. Second thing you need to do is find the median. What is the median? Well, think of the road. What's the median in the road? The middle. Now, one thing you're going to find out about statistics is driven around the center. Everything's driven around the center. Everything focuses around the center. So if you got a class of 30 students and everybody takes a test, the middle is the most important because that's where the hump of the curve is. And that's what everything is driven by in statistics. The center. Middle, center, median. Everything. The mean, the median, and the mid-range or midpoint or mid-range, whatever they call it, is supposed to be close together. If they are close together, your data is tight. That means your data is valid. If they are not close together, like 5 or 6 points away from each other, then that means your data is screwed up. That means you need to go back and take some more surveys or add some more people to your survey or whatever you're doing. Okay? Outliers throw numbers off. We'll talk about outliers when we get through doing this because you're going to see what the outliers are. Now, mode, not real important, but you need to know it for standardized testing. Range, mid-range, variance, and standard deviation. Those are the 5 things. Now, with data-driven set, how many there are, with a data-driven set, meaning test scores, meaning weights of fruit flies, meaning, I don't know, ages of people in the class, anything that looks like test scores, data-driven. That means you can find all of these things, and I will test you on all of these things, but I will only test you with a data-driven set. I will not ask you to find all of that with a frequency distribution. I will only ask you to find 2 things for the frequency distribution, and that is the mean and standard deviation. The mean and the standard deviation are one of the most important things in statistics. All right? So the first thing we got to do is find the mean. Well, if I asked you to define the mean, well, a lot of you, 90% of you would say, oh, well, the mean is you add up all the numbers and you divide by how many numbers there are. Yeah, that's the mathematical definition, but what is the mean? The average. Okay, what's the average? Define the average. Well, you take up all the numbers and you divide by the number of, that's what y'all, it's a cyclic thing. You just keep going around and around. But nobody can give you the definition of the mean. And I say that confidently because usually nobody knows what the definition of the mean is because it's more important that they program you to find the mean rather than you know what the mean is. Let me go to this screen right quick. I'm going to draw a picture for you. You can draw it if you want to, but if anybody ever asks you what the mean is, this is what you can tell them. In any data situation, you're going to have data and you can graph it, right? I should do this another way, but I'm not, so I'm going to go ahead and do it this way. And with that data, you can have a box plot or whatever, I mean a graph or a histogram, whatever, and it looks something like this. And let's say you've got about 15 of these things. I'm going to draw 4, and that's going to be it. I'm not going to do any more because I don't want to mess it up. All right, so there's your data. And let's say that this number right here is 10. And this is 15 or whatever. And this is 5, and you get the point. Now, if I take this guy right here, and I cut it off right there, and I put it, and I cut it off, and I put it, I stick it right in here. I done messed it up. I've got to add one more, sorry. And then I take this guy and I cut this off right here. And I flip it over and put it right here. Then what have I done? I've basically made a line that goes from here right about there. No, it's not right. I put it in the wrong place. Here we go. From here right across there, haven't I? And there's nothing that goes above it or nothing that goes below it. This right here, I'm trying, people, I'm trying. This right here is called variation, right? Everybody understand that? That's variation. The data goes up, then it goes what? Down, then it goes up, then it goes down. But what I have done, if I by doing this little yellow thing right here, by flipping this over and sticking it there, flipping this over and sticking it there, I have come up with a number that has what? I have come up with a number that has no what? No variation. So tell me what the range, what the range is. What the mean is. It's the number that represents what? No variation. So write that down. Because I guarantee you nobody in here knew that before you came in this class. If you did, I'll be very surprised. Anybody? The number that represents no variation. In other words, at that point, at let's say 12, let's say 12 is the mean. At that point in the class, there's no variation. Everybody is on the same level playing field at 12, or whatever the case may be. In this case, it's about 12. Now, why is that number important? I saw that. Why is that number important? Center of the class. How many of you have had a teacher? I'll never forget. I started seeing teachers about high school start putting up the class average and the highest and lowest grade. And I was like, what's he putting all that up for? Well, everybody likes to know how they compare with the class what? Average. Why is it the average? It's the number that shows no variation. So it's technically the data-driven center. That's what it is. That's why the average is so important. Okay? Okay, y'all are yawning too much, so we won't have to move on. This is boring to y'all. So let's move on. Trying to make it interesting, but What is the mean? You add it up, so let's go ahead and hit the little sum button here. And let's add up all these guys. And we're going to divide by what? That number right there. And that number is 83. So the average of your grades is 83. That number represents no variation in your data. The median. Well, remember, I'm going to go out here to the side. And I'm going to put if n is odd, then pick the middle. If n is even, average the two middle. So what is n? Well, look at it. It's 7. It's odd. So what do? 83. We'll highlight that yellow, or from around here, yellow, and we're going to put it right here. Mode. Remember, mode is kind of like most. MO. So it's the number that shows up the most. Now, you can have 2 modes. You can have 3 modes. You can have 1 mode. You can have 4 modes. But if you have 1 mode that shows up more than all the other 3 or 4, then it's 1 mode. The 3 or 4 have to be tied. There has to be none that's greater. It shows up greater. If one of them shows up greater than the other ones, you have 1 mode. It's the number that shows up the most. If you have 3 that show up the most, the same amount, then you have to put all 3. 25, 36, and 42. It's called trimodal. One mode, then bimodal, trimodal, polymodal. Do not. What number do you not put if there's no mode? What number do you not put? 0, because you'll have some SA teacher mark it wrong and say 0 is not even in the data. Of course, we know that you mean nothing. There's no mode. But it would be better for you to put no mode, does not exist, cannot be found, something. Write it in words. Just warning. Okay? So the E mode here? No. NA. Range. What is the range? Your highest minus what? Your lowest. So we'll go out here and say range is equal to highest minus lowest. Mid-range. Mid-range, parentheses, is equal to the highest plus the lowest divided by what? Divided by 2. The mid-range is pretty important. The mid-range is like the middle of the number line. And remember that when we get to the 5-number summary, so write that down. The mid-range is kind of the middle of the number line. In order to graph anything, you have to have either a number line or you have to have a Cartesian coordinate system, which consists of 2 number lines, a vertical and a horizontal. So when we get to the 5-number summary, you have to have a number line. And the number line consists of the lowest, the highest, and the mid-range. Okay, got that? And whatever's in the middle. And you can fill that in, infinite numbers in the middle if you want to. I don't want you to think that it's a part of, it's part of statistics, but it's more of a mathematical base part of statistics than the mean and the median. The mean and the median is more of a statistical part. The mid-range is more of a number line part. It's not statistical in a sense. One thing that it is the center. It's hard to explain because it is part of statistics, but it's more part of the number line than it is the statistics. It's kind of both, where the mean and the standard deviation and the median, those are statistical. not number line. Okay? So mid-range is your highest. Mid-range is equal to the highest plus the lowest divided by 2. Variance is a little bit different. Variance, you have to really rely on the formula to do the variance. And the formula for the variance is equal to the summation of x minus x bar to the second power, quantities to the second power, over n minus 1. Okay? Now, a formula in mathematics is like directions on a trip, or directions on building a bicycle, or putting together a bicycle. If you choose to throw the directions away, then don't get mad when what? You don't know what's going on. You've got to read the formula. You've got to read the directions. First of all, what is x? Well, I've established that x is each one of these guys, right? And I've established that the mean is, I haven't done that yet, I'm doing it now, is called x what? X bar. Okay? So you need to highlight the mean, and you need to put out the side of it x with a bar over it. So what does your formula say you have to do? Well, that's not rhetorical. I'm not asking you. I want you to interact. Huh? All I heard was, Say again? Not plug in, plug in each x, but what do I do with the x? What do I do with each x? Let me ask you that. There you go. You subtract the mean. So I'm going to make a column here, and I'm going to call it x minus x bar. X minus x bar. And I'm going to do that. Equals 75 minus this. And I'm going to lock it for those that in Excel, you know what that means. And there's my numbers. Now you do each one. You're the calculator. Go ahead and do that. See what you get. I want you to fill out your column by hand. If you don't have a calculator, use one on your phone. It ain't rocket science. It's just grocery math. Just 75 minus 83, 76 minus 83. Come up with those same numbers. I'll make them a little bit bigger for you. I thought I was going to make them bigger. There we go. Just do what the formula says. X minus x bar. X is 75 minus 83.4286. Fill that first column out. So do y'all's numbers match my numbers? Okay, so what do you do after you do x minus x bar? Well, you look over to the formula. What do? Well, you square it. You square each of those terms. I'm going to go over here and I'm going to say x minus x bar quantity squared. So that's equal to this number raised to the what? Second power. Take those numbers. I want you to have a column there too. I'm not one of these teachers to make you do it by hand every single problem of the test. I know you're going to use your calculators and I know you're going to use the Excel spreadsheet. But I think it's important for some things that you actually know how to find it by hand. Now, in chapter 6 and 7, I'm actually going to tell you not to use the formula because it's too tedious. All right, but the mean and the standard deviation, I think it's very important that you understand where it comes from. Because you don't understand what it does unless you understand how to get it. I'm not on the clock right now. Right.
How, like, for instance, how many decimal points would you tell us?
If you look at the directions of the homework or the test question, if it says go to the tenths, then you might want to take it to the hundredths and thousandths on calculations. And at the very end of the problem, always, with statistical data, always round at the end of the problem. Do not round during the problem. If the directions say round the answer to the tenth, then you want to carry all your data to the hundredth or 10,000th or whatever. You want to carry it 3 or 4 places, and then at the very end of the problem, when you get 32.3684, that's where you round. At the final, right before you type in your answer, that's where you round. You don't round during the problem. Now, if you want to pick a rounding point during the problem, you can. But if you pick to the hundredths, what should you do all the way through the problem? Round to the hundredths. Then when you get to the end, you'll round to the tenth. What the directions are. So the directions dictate what you round to. Now, hopefully your numbers coincide with my numbers. Now, what are we going to do with x minus x bar quantity squared? What does that funky looking E mean? That means summation, which means add them all up. So I go to my handy dandy Excel spreadsheet and I click summation and I add all those numbers up. No sneezing, please. And that is the numerator to my formula. So if I wanted to put a numerator here, that would be 275.7, whatever. 275.7. I'm not going to write the whole decimal, but that's over. And what is n? N is 7. 7 minus 1 is what? 6. So I'm going to find my variance right here. I'm going to say equals this number divided by, and I'm going to put in parentheses, this number minus 1. I get 46 is my variance. Does that mean anything to you? No. But why do I want you to get the variance? Because if you know the variance, then you know the standard deviation. What is the relationship between the variance and the standard deviation? Anybody remember from high school statistics? Good job, the square root. So take the square root of 45, and that's going to be your square root. Square root of 49 is 7, right? So the square root of square root of 46 is going to be like 6.8, 6.7. So let's go ahead and raise it to the 0.5 power. .8. Now, what the heck does all this mean? Now you're fixing to see where it comes in that you actually know what the mean and the standard deviation is. If you have a lot of outliers, well, let's look. Let's look at three things. And you need to highlight these three things because this is the numbers telling you about the data. First of all, you need to highlight this guy, of course, because he's the mean. And we'll put him in green per day. And then the median is also a measure of center. And the mid-range is a measure of center. What do those three numbers tell you just glancing at them? That your numbers are what? Tight. Your numbers are tight. Tight meaning valid. The opposite of tight is sloppy, loose. Okay? If your data is loose, watch what happens. Let's say you make a 32 on your first test, and you make 107, 110 on your last test. What happens to your center and your your center? What happens to the centers? They get discombobulated. They don't line up. If your centers don't line up, your standard deviation is going to grow. If your centers, look at your standard deviation. Dang, 23. But what was the first number? Let me just do this. But look at your centers are lining up. What is your standard deviation? Low compared to 23. So if your centers line up, that means your standard deviation is going to be low. If your centers are discombobulated, they don't line up, then that means your standard deviation is going to be what? Large. What difference does that make? Well, it's telling you as a statistician that your numbers suck. All right? And that you need to turn around and go back and instead of polling 75 people, you need to poll what? Maybe 100 people or whatever the case may be. It also tells you that you have outliers. It tells you that you're inconsistent with your test grades, which could mean one of two things. What are those two things? What are one of those two things? The teacher sucks, gives out an invalid test, or you study when you want to. It could mean one of those two things. Now, if you get a combination of those two things, then your numbers are going to be really screwed up. Invalid test, and you decide not to take the not to study, then you're going to get very low numbers. All right. The whole point is, what are the numbers telling you? The numbers should be telling you something, unless you don't know what they're telling you. Now, let me show you another thing right quick. I know I got like 10 minutes for those that are already starting to fidget. Let's take the middle, which is the mean. I'm going to put it right here. Sorry, there it is. And I'm going to add my standard deviations on the right. So equals this guy. And you need to write this down because you're going to be doing this the rest of the semester. I'm going to carry it out with three standard deviations. And if you had this class before, you know what I'm doing. I'm just adding the standard deviation on the right 3 times and subtracting it on the left 3 times. No, I hit the wrong button. I suck. There we go. Again, I'm going to highlight my median, my, whatever I call it, the average or the mean, the X bar. It's right there. And I added 3 standard deviations on the left, or on the right, and I subtracted 3 standard deviations on the left. So what is that called, Hubert? Well, that's called your normal curve. Bear with me a minute. I don't have a vertical line. I have to make them straight as possible. And then you take handy dandy veil maker curve. And you take your handy dandy straight line maker again. And there's your center. Now, in your book somewhere, don't ask me where, but somebody can look and tell me what page it is. You're going to look up, or you're going to see the empirical rule. E-M-P-I-R-I-C-A-L, empirical rule. I think I spelled it right. Somebody look it up and tell me what page it's on. I want to say 108 or something like that. I may be wrong, or 138. 138. Highlight that. Memorize it. Learn it. Because you're going to see it again, like on the test. It tells you that the curve is basically divided into several sections. And here they are. 1 standard deviation to the right, 2 standard deviations to the right, 3 standard deviations to the right. 1 standard deviation to the left, 2 standard deviations to the left, 3 standard deviations to the left. And it also gives you percentages. The percentages is what you need to learn. 34, 34, and then I always forget the middle one. I can't remember. The last one's 2.5 and 2.5 in some books. In this book, I think they stress the 2.3 and the 2.3, and then I think you got a 0.2 and a 0.2 on the outside third. Okay, I'm off a little bit. I'm not used to this book, but 6 of one, half dozen the other. The book you see next semester, if you take another statistics, is going to be different from this one. It's going to be 2.5 at the second standard deviation, and another 2.5 at the other standard deviation. So, and then the next book you look is going to have the 2.3, 2.3, and then 0.2 and 0.2 again. Doesn't matter. You just need to know both of them. Now, between these two guys right here, 95% is considered normal. I used to say normal, but now that my daughter's off to college, I don't say it no more. She used to say normal when she was in the 2nd grade or 3rd. And ever since the 2nd grade, I used to put normal across it, so I guess I might as well do it now. Anyway, normal, which means what? Normal. Normal. All right? Anything outside of 2 standard deviations, right here, is considered unusual. You need to write that down. And you need to highlight that area because it's a little area. And then outside of 3 standard deviations, for those that are not packing up yet, outside 3 standard deviations is called what? Outliers, which is your 300-pound 2nd graders. And your 6-foot 2nd graders. And your 1800 SATers in the 6th grade. Okay? Now, I'm not speaking for y'all, but I have no idea what those type people are because I consider myself somewhat normal. Okay? I don't play Beethoven's Fifth when I was 3 years old. I didn't do that. And I didn't do Fermat's theorem when I was in the 6th grade. So I'm pretty much normal. Okay? And unless you're one of these people that, you know, got a scholarship to Cambridge in the 6th grade, you're pretty normal. All right. So what did we learn today? Hopefully you learned something. You learned that the average, or the X bar, is tied in with the center, and the center drives everything, not S-I-N-N-E-R. Center, C-E-N-T-E-R, drives everything in statistics. Okay? All right. Now, what should you be doing for homework? Really? I really don't want you to do anything for homework in Chapter 3 right now. If you want to make up some problems and do what I did today, that's great. That'll be your homework. Do 2 or 3 in your notes. That's great. Do I want you to start on chapter 3 homework in the book yet? I mean, online? No, because I haven't covered everything yet. Okay? So, those of you that are not here, and some of you that have to be told 2 or 3 times, watch the video. Do not do any homework online yet in chapter 3. Now, let me go here and shut this off, and I'll take the roll. The remaining 2 minutes that I have.